Hello students, welcome to my YouTube channel SIP Rasayan. This is Indrani ma'am. Today I am going to start class 11 chapter 1 some basic concepts of chemistry. This is my first video. Today's topic laws of chemical combinations. What is laws of chemical combinations? There are 5 basic laws in chemistry which decide how the elements will combine to form compounds. These 5 basic laws are: number 1, law of conservation of mass; number 2, law of definite proportions or law of definite composition; number 3, law of multiple proportions; number 4, Gay-Lussac's law of gaseous volumes; number 5, Avogadro's law. Together, these are called laws of chemical combination. Now I am going to explain law of conservation of mass. This law was given by Antoine Lavoisier in 1789. He stated that matter can neither be created nor be destroyed. Now consider the reaction A plus B. You are getting C plus D. Okay. So here A and B are reactants. And C and D are products. So according to this law, law of conservation of mass, total mass of the reactants is equal to total mass of the products. Now we will see how to apply this law. So nitrogen plus hydrogen, we are getting ammonia. This is Haber's process ammonia formation reaction. In this chemical equation, in the left hand side and in the right hand side, number of atoms are not same. If number of atoms are not same in both the sides, then total mass of the reactants will not be equal to total mass of the products. So first we have to balance this chemical equation. Here 2 nitrogens are there, so here we can write 2. So like that way nitrogen atoms are same in both the sides. Here 6 hydrogen atoms are coming, so here we can put 3. So now it is balanced chemical equation. Now see here, total mass of the reactants, atomic mass of each nitrogen is 14. So 14 into 2 plus atomic mass of this 3 is coming here. Atomic mass of one hydrogen is 1 into 2. So it is coming 28 plus 3 to the 6. So 34 grams. This is total mass of the reactants. And in the product side, these 2 we are writing here. Atomic mass of one nitrogen is 14 plus atomic mass of hydrogen is 1. So 1 into 3. So 2 into 17, that means 34 grams. So therefore here total mass of the reactants is equal to total mass of the products. So law of conservation of mass is obeyed here. You can see here there is no creation or destruction of mass. Then what is happening here? There is recombination of elements taking place and we are getting new compound. Here it is ammonia. Now you can think, is law of conservation of mass always valid? Nowadays, the law of conservation of mass is not valid always. In nuclear reactions, a large amount of energy is released. In that case, a certain amount of the mass of the reactant is transformed into energy according to the Einstein's equation E is equal to mc square. So in such type of reactions, mass can't be conserved, but sum of mass and energy is conserved. Now we will solve some problems on this law. Number 1. 5.85 grams of sodium chloride will react with what mass of silver nitrate to produce 14.35 grams of silver chloride and 8.5 grams of sodium nitrate if the law of conservation of mass is true. Now first what we have to write? We have to write the chemical equation for this reaction. So it is given silver nitrate is reacting with sodium chloride. This is silver nitrate AgNO3. It is reacting with sodium chloride NaCl to form silver chloride. Silver chloride, you will get AgCl, you will get white PPT, white precipitate, plus sodium nitrate. Sodium nitrate means NaNO3. Now, what mass of silver nitrate it is asked. So we can write, let the mass of silver nitrate be x grams. Now see, these two are reactants and these two are products. Okay. Given the mass of sodium chloride is 5.85 grams. 5.85 grams. The mass of AgCl is 14.35 grams and mass of sodium nitrate is equal to 8.5 grams. According to the law of conservation of mass, total mass of the reactants should be equal to total mass of the products. Then total mass of the reactants X plus 5.85. Here AgCl is 14.35 grams plus sodium nitrate 8.5 grams. Therefore, if you add these two, it will come this 22.85. Therefore, X is equal to, it will come here 17 grams. This is your answer. Next problem. After adding 2.1 grams of sodium bicarbonate to a solution of acetic acid weighing 5 grams, it is noticed that 1.1 gram of carbon dioxide is released in the atmosphere. The residue is found to weigh 6 grams. Show that the law of conservation of mass is obeyed here. So what we have to do? We have to first write the chemical equation. Sodium bicarbonate, it is base and it is given acetic acid. This is acid, organic acid. Acetic acid. Acid plus base, you will get sodium acetate. This is salt, sodium salt of acetic acid. This is sodium acetate plus water plus carbon dioxide you will get. So these two are called residue here. Now what is given? Mass of sodium bicarbonate. It is given 2.1 grams. Mass of acetic acid is given 5 grams. So total mass of the reactants, it is coming 7.1 grams. After that, it is given 1.1 grams carbon dioxide. This is 1.1 grams. And residue is given 6 grams. So here also total mass of the product, it is coming 7.1 grams. So total mass of the reactants is equal to total mass of the products. Therefore, the law of conservation of mass is obeyed here. Next problem. On complete combustion with oxygen, 0.33 gram of a hydrocarbon gave 0.66 gram of carbon dioxide and 1.35 gram of water. Show that these results are in agreement with law of conservation of mass. Here hydrocarbon is reacting with oxygen. So we are writing hydrocarbon plus oxygen. We are getting carbon dioxide plus water. Hydrocarbon is a compound made up of carbon and hydrogen only. Complete combustion is taking place. That means hydrocarbon is completely converted into the products. Carbon is converted into carbon dioxide and hydrogen is converted into water. So what we have to do? First we have to find out the molar mass of carbon dioxide. You know atomic mass of carbon is 12. For each oxygen, atomic mass is 16. 2 oxygen atoms are here. So, molar mass we are getting 44 gram. So, 44 gram of carbon dioxide contain carbon 12 gram. Carbon 12 gram. Therefore, 1 gram of carbon dioxide contain carbon 12 by 44 gram and it is given 0.66 gram carbon dioxide we are getting here. So, this much gram of carbon dioxide contain carbon this much gram, 0.18 gram. Now we have to find out molar mass of water. It is atomic mass of each oxygen atom, hydrogen atom is 1. So 2 hydrogen atoms are there. Plus for oxygen it is 16. So total it is coming 18 grams. Therefore 18 grams of water contain hydrogen. How much? This 2 grams. Therefore 1 gram water contain hydrogen, this by 18 gram, 1.35 gram of water contain hydrogen, this by 18 to 1.35. Is coming 1.5, so 0.15 gram hydrogen. Therefore, mass of carbon after reaction is this much and mass of hydrogen after reaction is this much. Therefore, we can write total mass of carbon and hydrogen after the reaction is 0.18 plus 0.15. If you add these two, it is coming 0.33 gram. And total mass of carbon and hydrogen before the reaction is what? It was given in the form of hydrocarbon, that is 0.33 grams. So here after reaction it is 0.33 gram, before reaction 0.33 gram. Therefore, these observations are in agreement with law of conservation of mass. Clear? Next problem. Upon burning of 50 gram of unknown hydrocarbon produces 176 gram of carbon dioxide and 18 gram of water. This unknown hydrocarbon contains 4 options are there. 48 grams of carbon and 2 gram of hydrogen, 40 gram of carbon and 10 gram of hydrogen, 44 gram of carbon and 6 gram of hydrogen, 36 gram of carbon and 14 gram of hydrogen. So first we have to determine in 176 gram of carbon dioxide how much carbon is present. Similarly, in 18 gram of water how much hydrogen is present. That much gram of carbon and hydrogen was also present in the unknown hydrocarbon, 50 gram unknown hydrocarbon, according to the law of conservation of mass. You know, molar mass of carbon dioxide already in the last example we did it, 44 gram, and molar mass of water is 18 gram. So 44 gram of carbon dioxide contain carbon 12 gram. Therefore 1 gram carbon dioxide contain carbon this much gram. It is given 176 gram contain it is coming 48 gram. So unknown hydrocarbon was also having 48 gram of carbon. Now 18 gram from molar mass of water we can write 18 gram of water contain hydrogen how much? 2 gram. Therefore, unknown hydrocarbon was also having this much gram of hydrogen. Okay, so which option is correct? First option is correct. 48 gram of carbon and 2 gram of hydrogen.